Hello and welcome to day number 6 of Advent of Code. Again, we are going to try to solve two puzzles. Again, we are using Kotlin and we have our awesome helper with us, GitHub Copilot. Let's see how good this will work today. And yeah, I'm wearing a nice Christmas sweater again. Green elements that do not work with the greens. And just noticed I also green cup, which looks white, I think. No, it's darker. But yeah, let's go. I hope you have some coffee. Cheers. Let's start with day 6. Lanternfish. The seafloor is getting steeper. Maybe the sleigh keys got carried this way? A massive school of glowing lanternfish swims past. She never clicked on those links before, I think. Okay, so this is a lanternfish. I was actually expecting this fish with like the lantern to trick prey into coming nearby, and then they did, but looks like it's actually a different kind of fish. Anyhow, they must spawn quickly to reach such large numbers, maybe exponentially quick. You should model their growth rate to be sure. Okay. Although you know nothing about a specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. Okay. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. So suppose you have a lanternfish with an internal timer value of 3. After 1 day, its internal timer would become 2. After another day, its internal timer would become 1. After another day, its internal timer would reset to 6. And it would create a new lanternfish with an internal timer of 8. After another day, the first lanternfish would have an internal timer of 5, and the second lanternfish would have an internal timer of 7. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8, and does not start counting down until the next day. Realizing what you are trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish, your puzzle input. For example, suppose you were given the following list, 3, 4, 3, 1, 2. This list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on. Okay. And then after each day, they spawn new ones. Like this is 0, so it creates a new one. Now this is 0, it creates a new one. This is, why are there 2 8s now? Oh, there are 2 zeros. Okay, awesome. Got it. Each day a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. This example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5,934. Wow. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Your puzzle input. Ooh, okay. Save those. And then let's switch to IntelliJ and move the file over. Here's our input. Let's move it to the root again. It is day 6. And then we create a day 6 package again. Day 6. Main function. Part 1. And part 2. Okay, let's look at the data again. So we can load a bunch of fish. The question is, how do we want to represent this data? There are multiple options again, I think. To look at this. Like they are almost proposing one. We could create a list of those values, then add new ones at the end. And then essentially this list grows, and every day we go over this list and essentially do -1 on all of them. And if it's a 0, it becomes a 6. That is possible. Although I'm a bit scared. This list is already quite long. There are a lot of 1s, and they will all become 0s at some point. And then we will have a very long list. Yeah, what we could do instead is we only need to, we do not care actually about the individual fish. Like here, we do not care. For one, we do not even care about the position, that this is a 2 here and 2 here. Doesn't matter. It doesn't matter that this fish has a 2. We only need to know that there is a 2. So this one, if we write a comment here, like this one, we could represent differently as a map essentially. Like those are the only valid values, I think. And we could say we have one of those. We have one of those. We have 2 of those. 1, 3. And then we have 0, 4s. And then on the next day, we only need to move this data around, right? 0s become 6s. And for every 6, we add 1 to the 8s. And then we to move everything 1 up. This becomes a 1. This becomes a 2. This becomes a 1. And 0. Essentially, not sure how to show this in ASCII. Like, they all kind of move 1 up. This one becomes this one. And then we only need a map of 8 entries, which is super cheap. And I've, like, the moving up is simple. We need to make sure we do not mess it up, especially since those 7s will also move up. And will mess with the 6s we add from here, so we could first remember all the 0s we had, then move everything up, and then add those back in here, and add those back in here. Yeah, let's try this. And let's create a helper, fun read fish map, and it will be a map of ints to, or should we even use a map? Yeah, let's use a map. And then let's steal again our code. Oh, I didn't create a package. Package for day 6. Let's move this into day 6. Let's steal our code to read. And then this time we'll actually read the new file, day 6. And we actually only need to read one line, right? It's not this file. Look at this one. Yeah, there's only one line. Read lines, and then we only pick first one. And then split it by comma. And then we create the map. Mutable map. Oh no, not, sorry. Map equals mutable map of int to int. And then we loop over our values and count. Let's see what Codepilot is. It splits it. No, that is not what we want. We want to do a map. And then what's the get or default? That's what we want. For this value, we also need to turn it into an int. Maybe actually do this here already. Map it to int, yeah. And then we get the value. Current value is either the existing one or 0, and then we put +1. Okay, this is maybe a little bit confusing to read. Let's rename those. Those are fishes. It's not really better, I guess. This is a fish. And this is a kind of count. And this can be written as an array access. And then we have a fish map that we return. Awesome. And then we read our fish map. And then from main, let's execute part 1. And then let's print our fish map and take a look. Our awesome fish map. We are running the wrong one. I was very confused, but this is the answer of day 5, I think. Okay, file not found, day 6. Oh yeah, we forgot the ending. .txt. Run it again. Oh, we didn't actually rename it. Oh, come on. The automatic refactor. Day 6.txt to day 6.txt. That's not what we want. Okay. We have 15 5s, 28, 218 ones. Okay, let's try this. If we have a 5, it says 15 found. Okay, that seems all right. Now we need to, let's go back to day 6. Now we actually need to simulate. Do we want to do this on the map? Yeah. Let's write it as an... Yeah, let's write it as an extension function. Have a mutable mutable map of ints. And we have simulate lanternfishes on it as a function. Okay, GitHub Copilot, not Codepilot, Copilot, again suggesting crap. So simulate lanternfishes should only simulate one day. Simulate lanternfishes. Simulate lanternfish day. Well, you don't need to have the perfect name. It just should simulate one day, and we can use this as an example if it works. So first we need to remember how many zeros we have. Reproducing fishes is get for 0, and then we started at 8, I think. For how do we do this? We could reverse the key. Yeah, maybe we do this actually. Take the keys. But we need to start at the largest. Sorted by sorted descending, and then we go over them. Fish index, fish index, and then we to get the count. Let's make sure we do it right. Let's copy this over. There's a danger that we are overwriting the data we actually want to. If this is our map, and our goal is to should start at the lowest one, I guess. Because let's do this. Let's sort this list. So if we sort it descending as we are doing right now, then this list will look, or this map, or this list of keys, let's say, will look like this. And if we move 5 to 4, then we overwrite 4. This is not good. So instead, we should start at the bottom, I guess. Move 1 to 0, 2 to 1, 3 to 2. Okay, so we want to do sorted. We reverse this here quickly. This would obviously be much easier to write if we would have the list approach like described here, but that would be super expensive in memory and maybe too expensive for this list. So it's kind of a pre-major optimization, but we could maybe even calculate if it's a problem. But it feels like having a map with at most 8 keys, that is cheap. And now I'm wondering, we have zeros, do we need to move those too? Yeah, maybe we should actually move all of them, just to be sure. Yeah, do this. 1, 2, 8. Dot 8. So we start at 1, then up to 8, and then we fishes, or let's say count equals get e. There's none, it's 0. And then we say put at e minus 1 this count. Let's quickly try this with our example. So we start at 1 and then to write, let's do this, let's do this here. At 0 we write 128. Uh, 224, yeah, I think that should work. But now we need to fix 6 and 8. So at 8 we put, yeah, as it says, the number of reproducing fishes. Is this a problem? Oh, 0 at 0. And then at 6 we need to reinsert the fishes we already had, right? Okay, reset to 6. Yeah. So value. How do we? What is the name? Oh, I don't know a good name for this. The 6 fishes count. At 6, yeah. And then we put at 6 the 6 fishes count plus the number of reproducing fishes. And now we need to do this 80 times. So we have a fish map. Let's try this now. Then we simulate lanternfishes. And we print the map again. Is it red? Oh, this is not a mutable map? Yeah, let's just return a mutable map. Oops, mutable map. Get rid of the comment. So if we do this once, we should see the first map and the new map. So now at 0 we have 218. We've written those values now, but it's not important. Let's do it once more, then we should see some at 6 and some at 8. Oh, and print it. Okay, now we have 218 new ones. And we have those back at 6. And if we do this once more, then we should have 24 here. Yeah, let's do it one more. But it looks good, I think. Now they moved here. We have 24 new ones. This 0 moved here. The 24 is here. And one more, because what I want to see is, do we have, yeah, those should now be added to 218. This moves up. So they move here, the 19 will be added, yeah, and then 19, yeah, I think that looks great. So repeat 80 times, simulate lanternfishes, and now we print a new map. And those are a ton of fishes. Imagine we would have done this as a list. That would have been a lot of numbers in a list. What's the answer? How many lanternfish would there be after 80 days? So, okay, now we just need to sum the fishes, which means it's our fish count again. We take the values and then sum them. Values, sum total fishes is our fish count. So almost 400,000 fishes. Yeah, right answer. Let's see what part 2 has for us. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of a lot of fish. How many lanternfish would there be after 256 days? Okay, now I'm quite happy we used this map thing, because that is probably not possible in a list. Let's see. It's possible. Oh wow, that was quick. Ooh. This one is negative. Damn. Okay, ints are not enough. Let's rewind. First of all, let's go back to 80 here. This is actually now something we want to do in part 2. And we execute part 2. And in part 2 we say 256, right? Yeah. Okay. Int is not enough. Let's use a long. Too long. This needs to be on a long app. Oh, wait a second. This can still be an int. Sorry. Now it's getting confusing, but the index is still an int. So this can be, and this is an int, and let's run part 1. Do we still the right answer? Yeah. Let's see if day 1 is still working, or part 1. 394994. Okay. Now we execute part 2 with 256. It looks at least like positive numbers. So let's insert this long number. Awesome, right answer. We made it. That was day 6. Let me know if you were able to solve it and how you solved it. Maybe there's another interesting way to solve it with a map. I'm also curious if you were able to solve it with a list if you tried. At least part 2 with like those many fishes seems maybe impossible as a list. Maybe you have another great idea, let me know. Then I will see you at day 7. Bye bye.